Good morning, students. In the previous classes, we have started to solve the examples. So, the next example we have is x square plus 3x plus 15 by 2x plus 3 into x plus 3 whole square. So, resolve this into partial fractions. This is the question given. So here, this is clearly a proper fraction where the degree of numerator is 2 and the degree of denominator is 3. Because 2x, if you expand this, x square, so x square into 2x is 2x cubed. So the degree of x in the denominator is 3. So here, 2x plus 3. So in g of x in the denominator, 2x plus 3 is a non-repeated linear factor and x plus 3 is a repeated linear factor. Therefore, we can say that this is the combination of type 1 and type 2. So, x square plus 3x plus 15 by 2x plus 3 into x plus 3 whole square is equals to, for every linear factor of ax plus b of the denominator g of x, there corresponds to a partial fraction of the form a by ax plus b. So in this way, we'll get a by 2x plus 3. So this is the repeated. So type 2, b by x plus 3 plus c by x plus 3 whole square. This is equals to LCM is 2x plus 3 into x plus 3 whole square. So 2x plus 3 into x plus 3 whole square by 2x plus 3. These two gets cancelled. We are left with a into x plus 3 whole square plus b into this by this. X plus 3 whole square by x plus 3 gets cancelled for once. And we are left with b into 2x plus 3 into x plus 3 plus c into, these two gets cancelled. We are left with the c into 2x plus 3. So this is equals to x square plus 3x plus 15 by 2x plus 3 into x plus 3 whole square. So these two on both the sides gets cancelled. So here x plus 3 is a linear factor equated to 0, x equals to minus 3 we can use. And similarly 2x plus 3 is a factor equated to 0, x equals to minus 3 by 2. So x equals to minus 3, x equals to minus 3 by 2 or the two values that are going to be substituted for the value of x throughout the equation to obtain any two of the values of a, b and c. The remaining value we will be getting, the remaining constant we will be getting through the comparison of the quotient on both the sides. So here put x is equals to minus 3, substitute minus 3 whole square 9. So 3 into minus 3, 9 plus 15 is equals to, this on substitution gives 0, this on substitution gives 0. Minus 3 plus 3 is 0 into something 0. So c into the last one is 2 into minus 3, minus 6 plus 3. So minus 9. So these two gets cancelled. 15 is equals to minus 3c. Therefore c is equals to 15 by minus 3 is minus 5. This is wrongly written. This is not 3x, 13x. So this is equals to 13x. Now 2x plus 3 is a factor, x equals to minus 3 by 2. So put x is equals to minus 3 by 2, we will substitute 2. So this is 3 by 2 whole square 9 by 4 plus 13 into the value of x is minus 3 by 2 plus 15 is equals to, so this and this gets cancelled. We are left with the first term itself, a into minus 3 by 2 plus 3 whole square. This is equals to, LCM is 4. So 4 by 4, 9 minus Plus into minus, minus. 4 by 2 is 2. So 2 13s. 26. 26 3s. Minus 78. Plus 4 15s. 60. Is equals to A into 2 3s are 6. 6 minus 3. 3. 3 by 2 whole square is 9 by 4. This is equals to 60 plus 9, 69. 69 minus 78 is minus 9 by 4 is equals to 9a by 4. 9 9 gets cancelled. 4 4 gets cancelled. A value is minus 1. Now comparing the coefficients of x square on both sides. So here the quotient of x square is 1. Here on expansion, x square plus 6x plus 9. So the quotient of x square is a plus. Now this is 2x into x, 2x square. So the remaining terms are the x and constants. So 2x into x, 2x square, x square quotient is 2b. So from this 1 is equals to the value of a is minus 1 plus 2b. So 2 is equals to 2b. Therefore b is equals to 1. Therefore the final partial fractions for this is a value is minus 1. So minus 1 by 2x plus 3 plus b value is 1 by x plus 3 plus c value is equals to minus 5. So this is minus 5 by x plus 3 whole square. Resolve 1 by x minus 1 whole square into x minus 2. So the denominator contains repeated linear factor and a non-repeated linear factor. Here repeated linear factor repeated twice. So the constants are going to be a, b, and for this c. So a by x minus 1 plus b by x minus 1 whole square plus c by x minus 2. So this is equals to 1 by x minus 1 whole square into x minus 2 is equals to, here the LCM is x minus 1 whole square into x minus 2. So this by x minus 1 cancel for once. So x minus 1 into x minus 2 into a. So a into x minus 1, x minus 2 plus this by this. These two gets cancelled. So b into x minus 2 plus c into these two gets cancelled. C into x minus 1 whole square. So the denominator of both the sides gets cancelled. So 1 is equals to a into x minus 1 into x minus 2 plus b into x minus 2 plus c into x minus 1 whole square. So here x minus 1 is a factor, x equals to 1 is the root, x minus 2 is the factor, x equals to 2 is the root. So x is equals to 1 and 2 are going to be substituted in the for x throughout the entire equation. So put x is equals to 1. So 1 is equals to 1 on substituting here, it will be 0. And the last term is also going to be 0 because 1 minus 1 whole square is 0 square into c is 0. So we are left with the middle term. X value is 1 minus 2 is minus 1. From this b is equals to minus 1. Now put x is equals to 2. Substitute. 1 is equals to, here 2 minus 2 is 0. 2 minus 2 is 0. So we are left with the last term. C into 2 minus 1 whole square is 1 square. So from this c is equals to 1. Now all that we need to do is a comparing, because the two factors we have used here, comparing the coefficients of x square on both sides. Here we don't have any x square here. in the LHS 0. So here if you expand this, x square minus 3x plus 2. So x square quotient is a. And here also x square minus 2x plus 1, a minus b whole square. So x square quotient is c. So a plus c equals to 0. So from this, a is equals to minus c. So a is equals to minus c is minus 1. So a equals to minus 1. Therefore, 1 by x minus 1 whole square into x minus 2 is equal to, the value of a is minus 1 by x minus 1 plus b value is minus 1. So minus 1 by x minus 1 whole square plus the value of c is 1 by x minus 2. The next one is 3x minus 18 by x cube into x plus 3. So the denominator contains x cube, repeated linear factor, because x cube can be written as 1x plus 0. So this is the form ax plus b, repeated thrice. So a by x, b by x square, c by x cube, and here d by x plus 3. So this is a non-repeated linear factor type 1, repeated linear factor type 2. So this is equals to a by x, b by x square, c by x cube, d by x plus 3. So 3x minus 18 is equals to, so the LCM is x cube into x plus 3. The LCM is x cube into x plus 3. So x cube by x is x square into a into x plus 3. So ax square into x plus 3 plus x cube x plus 3 by x square. So x times into x plus 3 into b. So bx into x plus 3 plus c into x cube into x plus 3 by x cube. X cube gets cancelled. C into x plus 3 plus d into, these two gets cancelled. So d into x cube dx cube. So these two gets cancelled on both the sides. So 3x minus 18 is equals to ax square into x plus 3 plus dx into x plus 3 plus c into x plus 3 plus dx cube. Here we can substitute 0 for x and minus 3 for x in the equation. Put x equals to 0. 3 into 0, 0, minus 18. So here 0 square, here 0, and the last one will become 0. So we are left with the third term, c term, c into 0 plus 3 is 3. 3 minus 6 are 18. So therefore, c is equals to minus 6. Now put x is equals to minus 3, substitute. 3 into minus 3, minus 9. 3 into minus 3, minus 9, minus 18, minus 27 is equals to minus 3 on substituting here, it will be 0. This will be 0 and this will be 0. Last term, t into minus 3 whole cube is minus 27. So minus 27 on both the sides gets cancelled. We are left with d is equals to 1. Now the comparing coefficient of x cube on both sides. So otherwise x square on both sides. So we don't have any x square term on the LHS. It will be 0. So here x square into x cube and x square into 3, 3x square into a. So 3a plus here bx into x, bx square, x square quotient is b plus, that's it. So we get 3a plus b, but unfortunately we did not get any values for a or b. So you keep it apart and comparing coefficient of x cube on both sides. Let us see this. So the quotient of x cube on LHS is 0 because we don't have any x cube term here. So x square into x cube quotient is a. So here x square and x quotients are there. Here x and constants are there. X cube quotient is d last term. So a plus d. From this, a plus d equals to 0. From this, a is equals to minus d. So a is equals to minus, d value is 1. So a is equals to minus 1 we get here. From this, since we got a value, substitute here. 0 is equals to 3 into minus 1 is minus 3 plus b. From this, b is equals to 3. So we get all values a, b, c and d. Therefore, 3x minus 18 by x cube into x plus 3 is equal to, the value of a is minus 1 by x plus bx square, b by x square, 3 by x square, b value is 3, and the value of c is minus 6 by x cube plus d value is 1 by x plus 3. So this is the partial fractions for the given proper fraction. The next question is x minus 1, x plus 1, x minus 2 whole square. So the denominator contains non-repeated linear factor and repeated linear factor repeated twice. So this is whole power 1, this is whole power 2, 1 plus 2, 3 terms we are going to use for this. So a by x plus 1 plus b by x minus 2 plus c by x minus 2 whole square. So this is equals to x minus 1 is equals to a into x minus 2 whole square plus b into x plus 1 into x minus 2 plus 3 into x plus 1 divided by these two gets cancelled, so we can write directly. So put x is equals to minus 1. So minus 1 is minus 2 equals to, so a into minus 1 minus 2 is minus 3 whole square, 9. And remaining two terms will be 0 because x value minus 1, if you substitute here, this as well as this will be 0. So therefore a equals to minus 2 by 9. So x is equals to 2. 2 minus 1 is 1. So this is 2 minus 2, 0. 2 minus 2, 0. So we are left with the last term, c into x plus 1, 2 plus 1 which is 3. So c is equals to 1 by 3 efficient of x square on both sides. So we don't have any x square term here. So its quotient is 0. So x square quotient is a here. Plus here x square we are getting and the remaining terms will be x and a constant. So x into x square quotient is plus b. So a plus b equals to 0. From this b is equals to 2 by 9. Therefore x minus 1 by x plus 1 into x minus 2 whole square is equals to, the value of a is minus 2 by 9 by x plus 1. So minus 2 by 9 into x plus 1 plus b value is 2 by 9 by x minus 2. 2 by 9 into x minus 2 plus the value of c is 1 by 3 by x minus 2 whole square. 1 by 3 into x minus 2 whole square. Now, the next question is resolve 2x square plus 1 by x cube minus 1 into partial fractions. So again, this is a proper fraction with the degree of numerator is 2 and degree of denominator is 3. So degree of f of x is less than degree of g of x. And we have to see whether we can express this into factors or not. Can it be decomposed or not? So this is 2x square plus 1 by x cube minus 1 can be written as 1 cube. So a cube minus b cube is a minus b into a square plus ab plus b square. So x minus 1 into x square plus x into 1 x plus 1. Now, here the denominator contains this x minus 1 is of the form ax plus b, which is a linear factor of this denominator. So this is a linear factor. For every non-repeated linear factor, there corresponds to a partial fraction of the form a by ax plus b. So this, the partial fraction for this is a by x minus 1 plus. Now, this is x square plus x plus 1. So this is not a linear factor, it is a quadratic factor. It is of the form ax square plus bx plus c. So we need to see whether it is further decomposed or not. What I mean to say is it reducible or not? So x square plus x plus 1, so its discriminant if you find, then b square minus 4ac. So b square, x quotient is b square is 1 square minus 4ac x 1. So 4 into 1 into 1. So 1 minus 4 is minus 3, which is less than 0. So if the discriminant is less than 0, then this is the irreducible quadratic factor. So for every irreducible quadratic factor of the denominator, there corresponds to a partial fraction of the form ax plus b by ax square plus bx plus c. Already a is introduced, therefore bx plus c by x square plus x plus 1. So this is equals to 2x square plus 1 by x cube minus 1 is equals to a into x square plus x plus 1 plus b into x, bx plus c into x minus 1 by x minus 1 into x square plus x plus 1. These two gets cancelled on both the sides. Therefore, 2x square plus 1 is equals to a into x square plus x plus 1 plus gx plus c into x minus 1. Now, so x minus 1 is the only factor here for which equated to 0, x equals to 1 is the root, and root or solution has to satisfy the equation. So put x is equals to 1. So this is 2 into 1 square, 2 plus 1 is 3. So a into 1 square plus 1 plus 1, this is 3, and this will be 0 because 1 minus 1 is 0. So a is equals to 1 we get. Now comparing the coefficient of x square on both sides. So here coefficient of x square in the numerator in the LHS is 2. Here x square quotient is a plus bx into x, bx square quotient is b. So 2 is equals to, substitute a value here, so 1 plus b. So this is 2 minus 1 equals to b, or b is equals to 1. Now comparing the coefficient of x on both sides. So here x term is not present at the LHS, so 0. Ax square, a into x, ax, x quotient is a. Bx into x, bx square, bx into minus 1 minus bx, x quotient is minus b, plus c into x, cx, x quotient is c. So this is equals to 0 equals to the value of a is 1 minus b value is 1 plus c. So from this c is equals to 0. Therefore 2x square plus 1 by x cube minus 1 is equals to a value is x minus 1, a value is 1. So 1 by x minus 1 plus bx plus c, b value is 1. 1 into x, x plus 0. So x by x square plus x plus 1. The next question is resolve x cube plus x square plus 1 by x square plus 2 into x square plus 3. So here the denominator contains two quadratic factors. Which kind of quadratic factors? Reducible or irreducible? Irreducible quadratic factors, because b square minus 4ac. So b square here is x square quotient is a, x quotient is 0 and constant is 2. So a is equals to 1, b is equals to 0 and c is equals to 2. b square minus 4ac is 0 square minus 4 1s are 4, 4 2s are 8. So minus 8 is less than 0. Therefore this is a irreducible quadratic factor. So what does type 3 say? For every non-repeated irreducible quadratic factor ax square plus bx plus c of the denominator g of x, there corresponds to a partial fraction of the form ax plus b by ax square plus bx plus c. So according to this, there are two non-repeated irreducible quadratic factors. So ax plus b by x square plus 2, cx plus d by x square plus 3. So this is equals to x cube plus x square plus 1 by x square plus 2 into x square plus 3 is equals to, the LCM is x square plus 2 into x square plus 3. So this is ax plus b into x square plus 3 plus cx plus d into x square plus 2. So the denominator on both the sides gets cancelled. So we cannot substitute something for the value for x because we don't have any linear factors. Now all that we need to do is comparing coefficients on both the sides. So comparing coefficients of x cube on both sides. So here x cube quotient is 1 in the LHS. Here ax into x square, x cube quotient is a plus cx into x square, x cube quotient is c. So a plus c is equals to 1. This is the one equation. Likewise, comparing coefficient of x square on both sides. Here x square quotient in the LHS is 1 is equals to ax into 3. So 3ax. B into x square, bx square. X square quotient is b plus cx into x square, cx cube. Cx into 2, 2cx. D into x square, dx square. X square quotient is d. This is another equation we get. Now comparing coefficient of x on both sides. So we don't have the x term here, therefore its quotient is 0. Here ax into 3, 3ax, so x quotient is 3a plus cx into 2, 2cx, so 2cx, x quotient is 2c. So this is 1, 2, 3. So solving 1 and 3, we'll get solving 1 and 3. So first equation, let us multiply with 2. So 2 is equals to 2a plus 2c and 0 is equals to 3a plus 2c. These are the two simultaneous linear equations in A and C. Now this is equals to minus, minus, minus. So these two gets cancelled. 2a minus 3a is minus a is equals to 2. From this, a is equals to minus 2. So since we get the value of a, substitute this minus 2 in the first equation. Substituting a in the first equation, 1 is equals to a value is minus 2 plus c. So from this, c is equals to 1 plus 2 is 3. Now the comparing constants on both sides. So the constant in the LHS is 1 is equals to b into 3 3b plus d into 2 2d. Let us suppose that this is the fourth equation. So solving 1 and 4. So 2 and 4. So I'll multiply second equation with 2. Then we'll get 2 ones are 2. 2b plus 2d. So this is equals to 1 is equals to 3b plus 2d. So minus, minus, minus. 2 minus 1, 1 equals to 2b minus 3b is minus b. So these two gets cancelled. Therefore, b is equals to minus 1. Substituting b in the second equation. So this is equals to 1 is equals to b value is minus 1 plus d. So d is equals to 1 plus 1 is 2. So therefore we got every value of the so we have got the values for the constants a, p and c and d. So substitute here. So ax plus b, a value is minus 2 into x minus 2x plus b value is minus 1. So minus 1 by x square plus 2 plus cx plus d. So c value is 3. So 3x plus d value is 2 by x square plus 3. Third question. Resolve 3x cube minus 2x square minus 1 by x power 4 plus x square plus 1. So first of all, let us see whether we can express this into factors or not. So x power 4 plus x square plus 1. This can be written as x square plus 1 whole square minus x square. A plus b whole square. A square plus b square plus 2ab. X square whole square x power 4 plus 2 into x square plus 2x square minus x square is x square plus b square is 1 square is 1. Same. So this is equals to, this is a square minus b square. A square minus b square is a plus b into a minus b. So this is x square plus 1 plus x. A plus b into a minus b. X square plus 1 minus x. So therefore, x power 4 plus x square plus 1 is equals to x square plus x plus 1 into x square minus x plus 1. Now this is 3x cube minus 2x square minus 1 by x power 4 plus x square plus 1 is equals to 3x cube minus 2x square minus 1 by this x power 4 plus x square plus 1 is x square minus x plus 1 into x square plus x plus 1. Now the denominator contains two non-repeated irreducible quadratic factors. So we cannot express this into further factors. Since b square minus 4ac, so 1 minus 4, so this is minus 3. So here also the same. So since b square minus 4ac is less than 0, these two are irreducible quadratic factors. So irreducible quadratic factor type 3, non-repeated irreducible quadratic factor. For every non-repeated irreducible quadratic factor or quadratic factor ax square plus bx plus c of the denominator, there corresponds to a partial fraction of the form ax plus b by ax square plus bx plus c. So according to this, ax plus b by x square minus x plus 1 plus cx plus d by x square plus x plus 1. So from this, 3x cube minus 2x square minus 1 is equals to ax plus b into x square plus x plus 1 plus cx plus d into x square minus x plus 1 by x square minus x plus 1 into x square plus x plus 1. So this is x power 4 plus x square plus 1. On both the sides gets cancelled. This is what we will get. Now, comparing the coefficients of x cube on both sides. So here the quotient of x cube in the LHS is 3. So here ax into x square, x cube quotient is a plus cx into x square, x cube quotient is c. So let us consider this to be the first equation. Now comparing the coefficients of x square on both sides. So here x square quotient is minus 2 is equals to ax into x, ax square. So ax into ax square quotient is a, b into x square quotient is plus b. Here cx into x square cx cube, but we are taking the quotient of x square, so leave it. Cx into x minus cx square, x square quotient is minus c plus c, next cx, so d into x square, cx into minus x and dx x square quotient is plus b. So this is the second equation. Again, x square quotient we are taking. So ax into x square, x cube quotient we are not interested in. So ax into x square quotient is a. So next ax into 1, ax. So leave it. B into x square, bx square. So x square quotient is b. Likewise here, cx into minus x minus c, d into x square plus b. Now comparing the coefficients of x on both sides. So here we don't have any x term, so x is equals, so its quotient is 0. So here ax into 1 is ax, x quotient is a, b into x, bx, so x quotient is plus b, cx into 1, c, d into minus x minus d. So this is the third equation. And comparing constants on both sides. Constant on LHS is minus 1 is equals to, here b into 1b plus d into 1d. So b plus d is equals to minus 1. Let us suppose that this is the fourth equation. Substituting b plus d equals to minus 1 in the second equation. Then we'll get minus 2 is equals to a minus c. Here, the place of b plus d, I'll take it as minus 1. Minus 2 plus 1. Minus 2 plus 1 is equals to a minus c. So this is equals to minus 2 plus 1 is minus 1 equals to a minus c. Let us suppose that this is the fifth equation. The first equation is 3 equals to a plus c. Solving 1 and 5. So 1 is equals to a plus c equals to 3. So the fifth equation is a minus c equals to minus 1. So adding will get 2a equals to 3 minus 1 is 2. From this a is equals to 1. Now substituting a in the first equation, will get 3 is equals to, the value of a is 1 we will get right now, plus c. So from this c is equals to 3 minus 1 is 2. So a value and c value we got. Substituting a equals to 1, c equals to 2 in the second and third, then these two will be in terms of b and d. So solving the two simultaneous linear equations for b and d will get the values of b and d. So for this, substituting a comma c in the second and third equations, we get minus 2 is equals to a plus b minus c plus d. So from this, minus 2 is equals to, the value of a is 1 plus b, c value is minus 2 plus d. So this is equals to minus 2 gets cancelled on both the sides. We get b plus d is equals to minus 1. So let us suppose that this is the sixth equation. Substituting a comma c in the third equation, will get 0 is equals to, the value of a is 1 plus b value which is unknown plus c is equals to 2. In the place of c, substitute 2 minus d. So this is equals to b minus d. 1 plus 2 is 3. If you transpose on to this side, this is minus 3. This is seventh equation. Solving 6 and 7 will get b plus d is equals to minus 1, b minus d is equals to minus 3. So adding these two, 2b is equals to minus 4, b is equals to minus 2. So now substituting b in the seventh equation, will get minus 3 is equals to, b value is minus 2 minus d. So minus d if you transpose, this is d equals to minus 2. This minus 3 if you transpose, 3 minus 2 is equals to 1. Substituting a, b, c and d in the given question, x 3x cube minus 2x square minus 1 by x power 4 plus x square plus 1. Its partial fractions we have resolved it to be this. So the value of a is 1x plus b value is minus 2 by x square minus x plus 1 plus c x plus d. C value is 2 x plus 1 by x square plus x plus 1. So this is the required partial fraction.